You heard it.
Absolutely.
That was perfect timing. Thanks for queuing that up, Heather. Excellent. Okay, well, thank you so much, Jose, for the introduction. We're super pleased to be in partnership with a Northeast Gas Association to be able to host this special spotlight session today. Thank you so much to Heather, who has been extremely instrumental in helping promote this webinar, and we appreciate all the support. So next slide, please. As Jose mentioned, we have a all-star lineup. I'm very pleased to be able to be side by side with some industry titans. So we have representing, as Jose mentioned, the Chief Operating Officer of New Cosmos USA, Ron Lazarus. Also, Jonathan Diaz, the Engineer and Distribution Integrity Manager for Con Edison, New York. And also representing us, we're extremely pleased and proud to have Rick Treese, the Department Manager, Research, Development, and Demonstration, serving for Con Edison, New York. So thank you so much for joining us today as our special guests from Con Ed. And I am the Senior Marketing and Communications Manager for New Cosmos USA. So with that, next up, we will showcase a summary of what you'll be learning today. Next slide. All right, so you'll first hear an introduction to New Cosmos' innovative natural gas detection technology, as well as the growing need for natural gas alarm protection. You'll also hear about how New Cosmos battery-powered wireless natural gas alarms are quick and easy to install, ways utilities can leverage their existing wireless communications network and smart meters for the ultimate connectivity, as well as how Con Edison implemented a massive deployment of smart natural gas alarms. You'll also hear the interesting story of the success Con Ed has experienced as a result of the New Cosmos smart natural gas alarms and codes and standards updates. And then it will close out with a Q&A session with Con Ed. So the audience will be able to ask questions directly to our natural gas industry experts. Next slide. So at New Cosmos USA, our mission is simple. It's to protect people and property with innovative natural gas safety products. Now let's talk about our company profile next. Next slide. So here at New Cosmos, since 1964, we've been the world leader in residential gas explosion prevention. We are proud to be a company of firsts. We offer the first residential natural gas alarm in the world in the 1960s. We generate $280 million in company revenue each year. We're also #1 as the manufacturer of MEMS gas sensors worldwide. We have delivered over 70 million residential natural gas alarms globally, and we have 70% residential alarm market share in Japan alone. New Cosmos Electric founded New Cosmos USA in 2019 to prevent deaths in the US due to the success that's been experienced in Japan in virtually eliminating natural gas explosions due to natural gas leaks. You'll see a graph on the next slide, please. So in the 1960s, there was a high amount of natural gas explosions that were experienced in Japan, and there was a solution generated. So we offered the first ever natural gas alarm, as mentioned earlier. You can see that since the 1980s, there was a steep decline in the number of deaths due to natural gas explosions. And all the way to the right, you'll notice by 2019, deaths due to natural gas explosions were virtually eliminated. There were 0 deaths, in fact, in 2019 due to natural gas explosions. And so New Cosmos USA understands that there is a secret sauce recipe to being able to detect and prevent natural deaths due to natural gas explosions. And we want to be able to share that success and implement that in the US. Next slide. But let's take a closer look at some of the challenges that the US is facing. So clearly there's a lot of aging infrastructure with 1.3 million miles of gas pipes in the US. There's less than 1% of those gas mains are replaced each year. And it would take 230 years in order to replace every pipe in the US system. Certainly that's not realistic. When gas mains and pipes will take centuries to replace, you must be able to protect yourself now and minimize that liability. Certainly investing in a reliable natural gas alarm system that you can trust is key, and de novo detect natural gas alarms can offer that solution right now. Next slide. So why should we invest in smart technology? Well, over half the homes in the US offer natural gas as their primary heat source, and every 2 days, there are explosions that occur involving natural gas pipelines. So now certainly is the time to invest in smart technology that translates to the protection and detection you need. Next slide. And here are just a few examples we want to cite of what incidents due to natural gas explosions have occurred and ways that utility companies can be able to prevent this from ever happening again. We cite the Merrimack Valley, Massachusetts gas explosion back in 2018 due to excessive pressure in natural gas lines, which occurred during replacement of low pressure piping. The result was 1 death, 25 injuries, 30,000 evacuated and displaced. 40 homes went up in flames, over $1 billion in property damages, personal injury, infrastructure, etc. This all may have been preventable with de novo detect natural gas alarm installations. Next slide, please. Another example, Baltimore gas explosion in 2019. This was caused from large natural gas buildup, which was ignited when a stove was lit, with major dire consequences: 2 deaths, 7 injuries, 3 row homes exploded, and the community was devastated. And the Baltimore City Fire Department noted that this incident is a very tragic reminder of the importance of natural gas safety. So again, could have been preventable with de novo detect natural gas alarms. Next slide, please. Here in 2017, Public Service Electric and Gas had a major natural gas explosion, which was caused by a gas leak buildup after a contractor had damaged a gas line. 1 death, 7 injuries, and the blast destroyed at least 10 houses, damaging at least 45 other units in the complex. Now, this is important example to note that you can be taking all the precautions necessary by purchasing an alarm or doing everything to keep your natural gas under control. But Miss McGillicuddy and 13G apartment unit might have gas explosion, which a natural gas alarm would be able to detect that explosion and give you the time you need to escape. So again, could be preventable with de novo detect natural gas alarms. Next slide, please. Of course, we have to also mention the Manhattan, New York explosion of 2014, where the fire destroyed at least 2 5-story buildings, major devastation with 50 injuries, and 100 families and businesses displaced instantly. This, of course, could have been preventable with de novo detect natural gas alarms. Next slide, please. So after Con Edison experienced these tragic losses to their community, it was time to take action. And the gas alarm companies were evaluated by Con Edison to supply a massive deployment across New York. So this would never happen again. Next slide. And some of the reasons why Con Edison decided to select New Cosmos USA for their natural gas alarm deployment. We feel confident that some of the benefits included our MEMS sensor technology. Our New Cosmos proprietary hot wire semiconductor sensor with MEMS technology has 600 times more power saving energy when compared to conventional sensors. Also, there's no AC power needed. It's easy to install close to the ceiling with lithium batteries and is extremely selective to just methane. as well as being nuisance resistant to general household chemicals. We'll talk more about that. Next slide. So in fact, Gas Technology Institute did a test to reveal that our MEMS sensor was immune to typical household chemicals listed to the right due to our filter cap placed on the sensor. So basically GTI proved that our alarm is nuisance resistant to paint thinner, acetone, laundry detergent, stain remover, household ammonia, bleach, even hairspray, so that you can trust that you can plug it in and it does its job to selectively only alarm for methane. Next slide, please. Other product features that we feel confident that our customers continue to invest in our alarms are our 10% lower explosion limit, or LEL, gas alarm threshold. This essentially equates to 11 minutes faster on average escape time than our competitor products at 25% LEL. Our product also virtually eliminates nuisance alarms from common household chemicals, as we mentioned, due to the GTI confirmed testing. Our MEMS sensor technology offers up to 7 years of wireless battery life, and our battery powered device offers optimal installation near the ceiling. We also have voice alerts for residents in both English and Spanish versus our competitors with no voice alerts whatsoever. Our alarm is designed to protect against water ingress, and it complies with the UL 1484 standard. Next slide. So let's take a look at our product lineup. Next slide. Our current product feature sets. We offer a battery-powered advanced meter infrastructure, or AMI, MEMS natural gas alarm. It's a 7-year battery-powered alarm with Itron, LoRaWAN, and even a non-wireless alarm. Our future product lineup includes a 7-year battery-powered alarm with LTE integration and battery-powered MEMS natural gas alarm for 10 years with Itron, LoRaWAN, LTE, and a non-wireless alarm version. Next slide, please. Our natural gas alarms have been easily connecting and integrating wirelessly to utilities for a long time now. And some of the data that we found to be most critical for utilities are listed in the payload data section to the right. So they can see timestamps, the list of how many hours the alarm has been powered on, and then statuses such as low battery, system functionality, gas alarm notifications, and gas alarm concentrations. Certainly very important to monitor this data. Next slide, please. So our natural gas alarms are able to integrate seamlessly with this smart AMI network through mesh smart grid access points to communicate effectively with utility companies so that they can receive the data to provide the emergency first responders to respond appropriately to incidents as quickly as possible. Next slide, please. Now, that Con Edison knew that Denova Detect could do the job with our natural gas alarms, battery powered with appropriate installation. They were ready to partake in a massive deployment. And so let's see the progress. Currently, there are 60,000 alarms across Manhattan and Westchester rolled out with their AMI network. The goal, though, is 376,000 natural gas alarms installed by 2025. So we're just getting started. And in all, the major benefits of this partnership have really been providing a service to the community, the advanced technology of a smart gas alarm to residents free of charge. Next slide, please. So what happens if a utility company doesn't have an AMI network? We still have you covered. For utilities who are not currently using AMI or wireless infrastructure, but want to provide immediate protection for their customers, we have the best solution. Next slide. So let's take a look at the options here. On the right is our new Cosmos product. So Denova Detect natural gas alarms that we offer are actually the only battery-powered AMI and non-AMI residential alarm in the US. Our installation is optimally placed near the ceiling, which allows for earlier detection, quicker response, which essentially equates to saved lives. It's more accurate, and there's no additional cords or outlets needed. There's a quick install that lasts 7 years, so you can plug it in and trust it'll do its job with its innovative MEMS sensor technology. As opposed to competitor products where you'll experience installations, plugins near the floor outlets, offering later detection between 20 and 25% LEL, older technology, displeasing visual cords, false senses of security, and often misleading claims of 2 or 3-in-1 devices that simply don't function as promised. Next slide, please. So this particular slide is of great importance. I think it's a wonderful visual to show a natural gas leak simulation. In a typical apartment unit, a Fire Risk and Alliance did a study over the course of 57 minutes. What a natural gas leak simulation would look like. So first of all, let me step back and say, many people think that they're protected when they purchase plug-in units, but battery-powered natural gas alarms are much better and a safer solution, detecting natural gas quicker, and our alarms are proven to offer 11 minutes more escape time on average. So when it's a matter of life or death, it's certainly worth it to invest in a battery-powered natural gas alarm without question. So the purpose of this slide in particular is to show how gas leaks change over time. The Fire and Risk Alliance simulation shows that a natural gas leak starting over on the red on the top right represents the natural gas rising to the ceiling. As it rises, that's the natural flow of gas, since natural gas is lighter than air. And the green and yellow colors represent natural gas accumulated within an hour. Our Denova Detect battery-powered alarm installed in the appropriate location near the ceiling allows for optimal accuracy and detection at 10% LEL, represented by the black line, while competitor plugins are mounted near the floor. After 1 hour of a gas leak, no alarm will sound. This is even after an hour of dangerous levels of gas that have entered the room. So simply put, battery-powered alarms are better and safer solutions, offering easy installation near the ceiling where you need it most, and offering 11 minutes more escape time on average. So Con Edison chose New Cosmos USA as the best-in-class natural gas alarm for their massive deployment because they knew of the value that this 10% LEL offers and the battery-powered value in order to get the job done. Next slide. So together, both Con Edison and New Cosmos USA have pioneered the first ever massive scale deployment of smart AMI natural gas alarms to customers in the US. This is an incredible milestone to be the first, and it's worth noting the story of the strategic steps taken to get there. So let's hear from our very special guests, Rick Treese and Jonathan Diaz, to hear details of the timeline of approvals and deployment. And with that, let's hand it over to Rick Treese and Jonathan. Take it away.
Better off mute. Thank you, Julie. Next slide, please. Right now, there's an effort undergoing with the National Fire Protection Association to develop a fuel gas detection standard, a standard that the intent is could then be applied by authorities having jurisdiction to require natural gas detectors beyond what Con Edison is doing, where we're protecting the point of entry of the gas service into the building, and now, address the individual apartments, such as Julie mentioned, Mrs. McGillicuddy up in 3J, right, who has a gas stove and might have a faulty burner. So back in 2018, the Northeast Gas Association and Con Edison met with the American Gas Association Building Equipment Codes and Standards Committee, the BEX committee, and said, hey, we need support for a standard. And then later on, shortly after that, AGA then filed a petition with NFPA. You can see the timeline here. NFPA was looking for some data on it. They said, hey, you got to give us some rationale. And of course, we as operators, thoroughly understand the prior events that could have potentially been mitigated with the deployment of this life-saving technology. So we gave that over. And then, thankfully, it was... NFPA said, hey, this makes sense. They posted it for public comment saying we want to make a standard and received no negative commentary. So the standard process began. It was fast-tracked and we actually began it September of 19. And the first draft was completed February of 20. And if anybody has been involved with the NFPA process, that is fast. So simply what we did is we took NFPA 720 for carbon monoxide detectors, and that was the base document. And then we proceeded to enhance and modify that document to be suitable for gas detection. And when I say gas detection, the standard is fuel gases. So it also is addressing propane utilization. So that began public comment cycle for the second draft. We went through a first draft cycle, second public cycle went up, and actually this month we just finished reviewing that second draft comments from the public. You can see in the bottom right, serving on this technical committee, of course, is Con Edison and myself, Northeast Gas Association, represented by Bob Wilson. NYSERC is participating, the Gas Technology Institute, Fire Risk Alliance, who has done a lot of work testing and doing the studies of methane dispersion, which Julie actually showed one. So they're involved with us. And of course, New Cosmos is sitting on it, as well as many others. There's about 24 total members of the technical committee. Next slide, please. So this is the NFPA document, just shows you the timeline. So they have a very prescriptive process, and it's very formal. And I will tell you, if you have not dealt with the development of an NFPA, it's really a great process. It's very rigorous, it's formal, it's unbiased. It's just a great experience having with this, and I'm very impressed with the organization. So the final comments we're up to for reviewing the second draft, you can see, is highlighted November 9th, and that'll go out for ballot. And if everything proceeds on time schedule, by this coming May, and I like to say, because before we used to talk many, many Mays in advance, now we're saying it's this coming May, we hopefully will have a standard that could be adopted for the installation of natural gas detectors beyond a utilities application of that. So next slide. So in New York, what we're really excited for, what Con Edison is really excited for, is this standard could now be applied, hopefully, by New York City Department of Buildings. New York City, back in December of 16, the mayor promulgated Local Law 157. Which revised the administrative code, the New York City Administrative Code, to add in the requirement for natural gas detectors. So it already had a requirement for carbon monoxide detectors, for smoke detectors, and it modified that code to now say natural gas detectors are required. But, and there's a but, natural gas alarms shall be provided and installed in accordance with section 9.908-1 of the New York City Building Code on it before a certain date, right? After a standard governing their installation and location is developed. So there is no action item in New York City at this point because there is no official standard, and we're really going to be pushing for the adoption of NFPA 715 to meet that requirement. because the New York City building code, of course, utilizes NFPA standards throughout for safety. And at that point, once NFPA is available, we re-engage with the building department and hopefully get productive talks, which will then add teeth to a regulation that has no teeth right now. So next up is Jonathan, and Jonathan has some great stories on our deployment. Jonathan.
Thank you, Rick. I appreciate it. And thank you, New Cosmos and the NGA for having me. As always, it's very good for me to talk about our information, what we have gathered, what we're seeing, because we just want to show that this is very possible. Yes, we're learning, we're adjusting, and this is what it's all about: gathering data, learning, adjusting our program, and getting better at it with the help of New Cosmos as well, because we provide them feedback on everything that we find. So that's a very interesting partnership that we have with them, because they get our feedback and they also get to improve their detector based on what we give them. So we started back in 2018 with our pilot program. We did 9,000 detectors for our pilot program in Westchester and New York City, in Manhattan in particular, so that we could understand different things as related to this detector. And since then, we started our mass deployment program a year ago, and so far over 60,000 detectors installed, as Julie mentioned before. So we have seen a little bit of everything, which is good. You want to see a little bit of everything so that you can learn early on and adjust as you move forward, adjust your program. And that's some of the things we saw at the beginning of the pilot program, was that we were getting a lot of leaks at couplings and fittings, inside fittings, elbows, that sort of thing, unions, couplings. So we adjusted our program. We said, all right, we need to change. So we needed to change our approach for the installation of detectors. So we implemented pre-inspection prior to that installation, so that we can mitigate some of that, right? So we have a lot of categories in this. I won't touch on all of them. I'll touch on some of them. And as always, if you have questions, we'll answer them in the later sessions. But some of the typical questions that I get related to the alarms by category is obviously false alarms. What does residual gas mean? And what else have you found? Some of the things that we have found that we did not expect was the unauthorized piping operation. So what does that mean? That means that a contractor, whatever it was, plumber or any other type of contractor, or a homeowner, operated our equipment, meaning our valves, or took down our meters, or took down piping without us knowing, without submitting an application for service. Therefore, since they may not be familiar with the detector, or they may not be familiar with the sensitivity of the detector, they're releasing that gas in that basement, or operating something they shouldn't and leaving a leak behind, which does happen. Sometimes they do leave an open-ended appliance and don't realize that the appliance valve is not properly shut, or perhaps the valve is leaking. So we get those, and we did not expect to see that when we started the program. So that's a positive thing, because we want to make sure that obviously customers and contractors are aware of the processes that they need to do. But it's also good for us because we're getting there to that location in a timely manner and addressing the situation with the customer or the contractors. In terms of the false alarms, that is what you make it to be. So what do you determine a false alarm to be? And for us, it's different things. So we had different categories for that. But most people would say, okay, a false alarm is you went to the location and you necessarily didn't find the reading, right? So sometimes we might have that. But in general, we really haven't seen much of that. The majority of alarms have had something to do with methane, pipeline methane. So we are happy to find those leaks, and we adjust as we go. So that's really, false alarms is really what you make them to be, right? And then one of the other categories is residual gas. What is that? So perhaps we're doing a scheduled service replacement. You vent the pipe, you vent the gas inside the pipe out into the atmosphere, or whatever the case is, or you burn it out. But there's always gas, residual gas inside of that pipeline, inside of those pipes, those service pipes, inside of those meters. And when you take it down, you're going to have some of that. And some of that sometimes makes it into the detector. And it's more of an awareness issue for us. We have a lot of contractors doing main replacement. We have a lot of contractors doing meter replacements, et cetera. And sometimes they may not see the detector or don't realize what they have to do just because of awareness. There's a high turnover of contractors coming in and out of our system. So getting the awareness out is very important, and we try. We give them OJTs, we give them tailboard talks, etc. But there's always that risk that somebody in the crew may not have been exposed to the detector in terms of awareness. So that's about awareness for the most part. We've also had some sewer readings. We've also had a lot of outside leaks, very good outside leaks to discuss. We had a couple of damages here, one inside and one outside. The one inside was very interesting, and the one outside was just a contractor damage, and the leak migrated into the building. So overall, we've seen a good amount of categories, and we take this data, and I'll show you later what we do with this data. So this is all about continuous improvement. And we give this data back to new customers so they can also improve our detectors. So for example, the battery compartment, it's kind of difficult sometimes to open the battery compartment. So we discussed it with new customers, we showed them, and they adjusted that. The hook on the detector, we wanted to adjust the hook on the detector, and they made an adjustment. So all of our findings have a purpose. Is to meet with new customers, give them our feedback, and see how the detector can always be improved. And obviously, we're giving that benefit to the utilities that come behind us, because they'll have the benefit of our findings as well. Okay, next slide. All right, and now I'm going to touch on some of that data, one of the improvements we did with new customers, and you can go to the next slide. Is we wanted to understand a little bit more about some of these leaks. Do we know what's happening at the time of the alarm? So one of the adjustments that was made in the software of the detector is the ability to send us readings, LEL readings at the time of alarm. So at the time of alarm, the readings coming into our system through the Itron heading system, and they send us a signal every 30 seconds when they enter the alarm. That is used to graph and to send an email to our emergency responders in the control room, so our gas emergency response center. They get that link, they open the link, and they can see live what is happening at the location. And this is an example of that. We have a few. And the purpose of this is to learn, right? We want to understand, okay, what is happening with different types of leak findings at the time of alarm. How can we adjust our response? Our response requires the fire department. So we want to adjust that so that we don't have to call the fire department in the future for every alarm. If we think this is a type of alarm that it doesn't require an enhanced response, then we'll adjust. So the purpose of that is that also to learn what do different leaks, how do they display? How do they show up on a chart? So this is just one of those. For example, this one, and they all start at 10% LEL because that is the threshold of the detector. And from there on, it can either go up or go down in increments of 5. And the part of the adjustment on the software is to have it every 1% increment. So we'll have that. And the top, the highest point that the detector can go is up to 25% LEL. So that's the highest reading we'll see on the display. And this also tells us, all right, what is happening between the alarm time and the arrival time? Is the leak getting better? Is the leak getting worse? Do we need to adjust in the future? So this happened to be an authorized piping operation where we had a coupling being removed by a plumber and the detector went off. Next. And this is another one. This is one where we had a building fire, right? So the building fire triggered the detector. We don't necessarily understand what occurred or whether or not there was gas involved. The fire department says there's no gas involved. But what do we do about this? Why is a building fire setting off the detector? So we also partner with RIG 3S and the Research and Development Department, and they have partnerships with other companies. The Fire and Risk Alliance is one of them. And we go out and we tell them, look, we want to study why this detector is going off during a building fire. We want to understand what happens during a smoke condition. So we do that as well. So this is also helping us understand that. Do we need to change something? Does smoke or CO create any type of alarm on the detectors? Is there anything happening at that point in time? So we also take this data and go out and continue to improve our understanding of these detectors and what they provide. So this is definitely new for us and new for many. So we continue to learn. Next. And this is another one where we had a leak at a gas meter. So this is important. A leak at a gas meter typically is something very low flow because it's typically just either an expansion or contraction of a connection, or it could mean the meter dial perhaps is leaking through the gasket, etc. So this is also helping us understand how these type of leaks behave in an environment where the detector is located. So this is what we do. We take this data, we analyze it, we review it, we compare it, we take notes on it, and we adjust either our response time, or we adjust the detector, or we adjust something in the process to make us better all along in this journey. And that's basically what I have. Next. We have some questions for us. I saw a couple of the questions, and we can start answering those, or should we go through the Q&A? I think there were some questions already in there, Julie.
Yeah, Jonathan, let's give priority to our attendees. There are a couple questions that, as you're correct, we're seeing come in. So one easy question is, will the presentation be available to send to us? And I think Heather can go into more detail, but the session is being recorded and will be available on the NGA website channel. That's correct, Heather?
Yes, Julie, it'll be available on the NGA Learning channel. So all NGA members have access to that free portal with great information.
Great. And then another question by Brian Sullivan was, is Con Edison installing these with its own internal staff?
We use contractors to install the detectors. We have a deployment force, deployment contractors that are doing that. But our purpose or our goal is also to use our own internal resources, our GDS mechanics, to be able to replace these detectors. So we're heading in that direction for them to do that. But for mass deployment, we have contractors doing that.
Thank you, Jonathan. Another question has come in. Has New Cosmos done any work of this nature with Avangrid? That would be a question for the New Cosmos team.
We have not done any work with Avangrid as of yet.
Thank you, Ron. And
Julie,
yes,
there's a question before that as well. From is it you, Joe Mandera? Would one of these be needed at each point of entry into the basement? So yes, we install one detector per point of entry, but only the point of entry that is facing the street. So sometimes you have that extension of service where it might be there might be the first POE might be, let's say, in your garage or in a front home or some other structure such as a building or a guest house, and then it extends into another home. We would install one at that point of entry, the initial point of entry where a gas pipeline enters that premise. If there is multiple meters, for example, outside, but only one point of entry, then that's the point of entry that we use. And for example, a corner home where water comes in one street and gas on the other. No, we use the gas point of entry for this.
Julie and Jonathan, let me just add one critical point that I just want to make. It wasn't a question, but our installation of natural gas detectors is protecting the environment we're installing, right? It's not a comprehensive installation to protect the entire structure from leaks within the entire structure, right? So your potential leaks are with this utilization equipment. So if there's a multifamily building, there's a gas fire, if single family home with a gas fireplace on an upper floor in a bedroom, a kitchen stove, right? This detector is not going to detect that, right? If multifamily building, 20, 30 stories, each apartment, it's not going to detect the individual occupancy. So we are looking for gas by our gas point of entry into the building, and it's adjacent pipe covered by service line definition. Thanks.
There was another question that came in only for gas POE, not concerned with other routes of entry.
Huh. All right. So let me elaborate a little further. Right. So right, we're looking for gas following the gas POE. The operators are on the call with us now know that gas will follow multiple paths. They'll follow buried electric lines, sewer lines, of course, telecommunication conduits. Any conduit into the building could serve as a pathway for natural gas. And obviously, if those conduits, like sewers, are in proximity to the gas point of entry, then it would be afforded the level of protection from our installation. But if it was, as Jonathan mentioned, another part of the building, it's not. One leak actually we did have was that I can remember early on was gas following in through a telecommunications conduit, and that set off the detector because it was in I think around 6 or 8 feet proximity, and it was up high in the wall too.
Yeah, and just to add to that, in our service territory, we see that a lot where the infrastructure, the underground infrastructure tends to enter in the same area as the gas POE. Newer construction might be a little bit different, but in general, we do see gas, sewer, sometimes water, telephone, or underground electric, if there is one, in the same vicinity. So we tend to protect that area where all of those other POEs tend to be as well. But that's not for every case. So that's correct. We look for the gas point of entry. We are concerned with the other points of entry, but we mostly look for the gas point of entry.
Thank you both for that clarification. So Brian Sullivan has another question. Based on comments earlier, I understand the expectation is that these gas detection alarms may become a building code requirement with the issuance of the final NFPA 715. Is that correct?
That's our hopeful outcome, right? The NFPA is a standard, and in and of itself, it's not enforceable. It's not applicable unless an authority having jurisdiction adopts the standard. So that's our goal, is to have the NFPA available for jurisdictions to adopt.
Mm-hmm. Excellent, excellent. Thank you. Will the building code change require the LDC to install these, or home builders / owners in their spaces?
Well, once again, the NFPA, if I'll use New York City as an example. If New York City amends the fuel gas code to adopt NFPA 715, then yes, that would require new installations to meet a certain installation criteria upon construction or renovation, and existing structures to add in units, right? And that's why battery units are so important, because existing structures never have to modify their wiring. They simply need to deploy a technology, and a battery operated device would suit that end.
That's a really good point. Thank you, Rick. And Chuck mentioned that just clarification around New Cosmos devices. Are these detectors class 1, div 1? Perhaps.
Yeah, let me, if I may, touch that too. So the devices that Con Ed is installing, first of all, the New Cosmos device, that we are installing, was designed, and its base model was certified to Underwriter Laboratory Standard 1484. And that standard requires that the source of gas being detected, the gas source, is not an ignition. The device won't serve as an ignition for that gas. So it's not, an IS certification, but it is a requirement that the detector will not ignite the gas. Now, I will also say, I mentioned UL 1484. So then we took the UL base model that it was certified to, and then did some Con Ed modifications to remove some of the functionality you would want a consumer device to have, such as the ability to turn on and off, the ability to hear non-alarm detects, like low battery alarm or sense of failure, which aren't detection alarms. We don't want the consumer to hear that. So we asked New Cosmos to modify that to take those as silent, and they are transmitted to Con Ed. So the functionality is there, but it's silent to the consumer. So once again, the AMI version we are installing is modified from UL 1484 certification for that.
Thank you, Rick. So another question here is from Mohammed Tambra. He's asking how many lives are potentially saved by deploying 60,000 methane detectors. And this may be a difficult question to answer, but one data point I think we can look at is just already in the deployments of 60,000 alarms, the amount of leaks that have been found and identified, I think, was in the range of 125. So, you know, however many residents are living in those 125 spaces, you know, what that equates to in terms of numbers. But does anyone have any thoughts?
Yeah, Jonathan, I'll let you, if you want to chime in after me. I will tell you there are 8 souls lost in Harlem, East Harlem, that would be with us if this detector was in the basement. So the detections we have been receiving have not been accumulations of dangerous concentrations, right? I'll say dangerous, right? Gas in air is not acceptable. We all know that, but as operators, we also know that the danger does kick into different levels, and we haven't had that. And actually, that brings up a very good point. I want to just elaborate further, is that the alarm is set off they'll go off at 10% of the lower explosive limit, right? So that's 0.5% gas in air. It's a lot of gas. And what we're finding is that the alarms, so we didn't have 631.5% gas in air concentrations, right? Because I will tell you quite frankly, that would be very scary. You know, Jonathan could elaborate further on how many we've actually had a gas in air reading. What we're finding is the leak plume is going past the detector and then dissipating. So when we get there, we are not able to measure a gas in air concentration, but there is a gas leak, and that plume that flowed past the detector set it off. So we are getting there so far in advance of any type of accumulation that, you know, one day I will tell you, we will document the saving of a life. It's coming. I hope not in the near future, but I tell you, it's coming. Jonathan, anything to add on to gas and air concentrations?
Sure. Yeah, it definitely is difficult to quantify it. At least for our service territory, we serve about 1.2 million customers. For the 60,000 we have installed, that's mostly in Westchester, and in Westchester we have about 145,000 customers or so. But it's not just about the outside leaks. The inside leaks also pose, and equipment in particular, customer equipment also poses a risk. And we've seen that. We've had gas heaters, very ancient gas heaters, if you will, very old gas heaters that have failed inside of a home. And gas has migrated 10, 20 feet inside of the home and has made it to the detector. And we have gotten to that location in time to vent the area, evacuate the customers, and fix the situation. Also happens all the time, not just from the detectors, but we've seen it also from stoves, you know, appliances, knobs being left on, people are leaving their appliance on and not realizing that. So it's also serving that purpose. We've seen it from the last storm that New York has a lot of apartment basements. And in apartment basements, you have apartment appliances, stoves, etc. So it's not just the outside leaks. We're also finding leaks from equipment inside of these buildings that we're helping mitigate a possible larger event. So we started this program to make sure that outside migration doesn't become the next Harlem, but we're also realizing that inside leaks, inside malfunction of equipment, hoses, etc., can also pose very high risk to a bad event.
Thank you, Jonathan. A really good point.
And Julie, I just want to clarify one comment earlier, because I've seen a couple of items in the chat, and that's regarding Avangrid. And when I was asked earlier if we have been doing business with them, I thought it was referring to the AMI. And it was pointed out that they are installing our non-AMI in some of the New York, and like through RG&E. So I just want to clarify that.
Thank you for that.
Hey, Julie, before you go on, I just want to talk about one second. Our pilot program, not pilot, our program. I got to tell you, it's really our partnership with New Cosmos is really enhancing this product so much quicker than would be done by a manufacturer in a lab setting, right? Because remember, every alarm we go off that does not have an immediate identifiable reason, New Cosmos evaluates the unit. So there's a lot of feedback back and forth that serves to enhance the product much beyond a product release.
Yeah, certainly data is extremely valuable in monitoring the alarms. Kyle, can you go back to the last few slides that discuss the alerts? Yep, exactly. Here we go. So this is perfect for the LEL readings. I just wanted to point out, we have about 7 minutes left, and here we can answer some of the audience questions, some questions that we had previously teed up. But getting to this slide, the gas alarm LEL readings here are citing how quickly Con Ed's team is responding, where there is an alarm and within 2 minutes, their center is dispatched and then arrive on scene in 9 minutes. I mean, that's incredible, and really saving lives potentially here. So on this slide though, we're gonna stay on this slide to answer the question from Gary Wilcox. How is the alarm sent to your emergency center, and what does the emergency center personnel see?
So we use the Itron communication system. The detector uses an Itron Mili5 communications card. The detector works in a way that when the alarm goes off, it starts to send signals every 30 seconds. And that signal, that payload, we call it the payload. The payload includes different information. And one of the pieces of information is the LEL reading at that time. That information makes it into the Itron head-end system. With the Itron head-end system, we created a dashboard. With that dashboard is fed from this information. And as soon as the alarm comes in, which is typically a minute or under, so the alarm goes off in about a minute or so, the Gas Emergency Response Center sees the alarm on the system, the ticket is automatically generated, and this dashboard is automatically generated. So all they do is click on a link, the link comes up, and they start to see the readings on the detector as it progresses. So it's using the Itron head-end system. We collect the data, we display the data internally through our IT systems. The Gas Emergency Response Center is able to use this data, but they do dispatch an emergency responder as soon as they know about the leak. And they also dispatch the fire department, the local fire department. And the point of this information is to learn. It's still too early for us to determine when not to send the fire department. So we're still reviewing data and gathering data. And the point in the future will be so that we can determine when to and not to send the fire department, so that we can alleviate that response when it is not necessary.
Excellent. All right. Thank you for that. There are two more questions that I see. One is there a partnership between LCDs in installing the NGD where one has gas and the other electric AMI?
Let me touch that. I remember internal company discussions on that, recognizing just Con Edison's franchise, gas franchise, is part of New York City, and I could talk as an example. We use Con Ed, right? So we have the entire electric franchise, and this system, this detector we install, requires the electric meter. This detector communicates to the electric meter, AMI meter, and goes up to the network. So our deployment of natural gas detector requires our electric meter. And obviously, there is another operator of natural gas in New York City that is in our electric franchise. So I remember a discussion internally saying, are we a utility or are we a telecommunications company? So it begs a very good point that requires, I think, more discussion, as to whether ratepayers in different gas franchises could benefit off of what is being paid by the other franchisor, the other ratepayer. So no answer, but it makes a good point.
Thank you, Rick. Another question from the audience. What are the communications capabilities of non-AMI detectors, if any?
Yeah, the non-AMI detectors do not have any communications capabilities.
Okay. All right. So with that, that's the end of the audience questions. I would say if we go to next slide, next slide, next slide, next slide. Perhaps we can get one question in here with two minutes left. So let's reiterate, I think in summary from Con Ed, there was an immediate need to supply our residents with new natural gas alarms to provide safety and security they needed. So what were some of the most important gas alarm features that you looked for?
I'll touch that. UL 1484 is the governing standard for consumer product, and that prescribed a minimum alarm of 25% of the lower explosive limit. And you want to do the math, it's 1.25% gas and air. And as operators, we know that that's just an exorbitant amount of gas. So we wanted to get the alarm set point to be more closely aligned with the odorization standard in New York State, where gas has to be readily detectable to 10% of the lower explosive limit by a normal sense of smell. So based on that New York State requirement, we believe that a 10% alarm would be more appropriate. Recognizing a lower detection probably is always better, but we settled on 10%. And the other thing we required was a battery. The device had to come with a lifetime, the device lifetime, right? Battery. And right now we're up to 7-year lifetime. So that was critical because our experience with the commercial products that are electric powered, they had a 9-volt battery backup. And if you unplugged it, it would be dead in about a day, and it would give a low battery alarm. So obviously that type of technology just was not suitable for a utility application as ours.
I know we're running low on time here, but I just wanted final thoughts here to give to you on any advice going through the experience that you've had in massive deployment on massive scale to other utilities who might be rolling out this soon.
Embrace the technology and start installing them. They will save a life. I just can't say it any plainer than that. And if you have any some people in the room who might remember the rollout of carbon monoxide detectors, well, technology has progressed since that initial deployment of those safety devices in the 90s, and let's not live on legacy issues, right? We don't drive Model Ts anymore, we drive Teslas. So let's start using Tesla technology.
Thank you so much to our Con Edison representatives and special guest speakers, Rick Treese, Jonathan Diaz, and Ron Lazarus, representing us from New Cosmos USA. Thank you to Northeast Gas Association for hosting this special spotlight event. Can you go back one slide, please? There we go. Any and all of you are welcome to connect with us. We look forward to hearing from you. Please contact us. Ron Lazarus is able to receive any questions you have. If you're looking to collaborate with us, definitely connect. Let us know how this presentation was if you have further questions, and give us a follow on LinkedIn at Genova Detect by New Cosmos USA. On behalf of New Cosmos USA, thank you so much for joining us today. And with that, I'll give it back to Northeast Gas Association. Thank you.
Julie, thank you. And there was one question for those of you that are asking if you can get a copy of this presentation other than through the channel, if you're not NGA members, especially for those regulatory people from our regulatory community, our partners, definitely let us know. You can email us and we'll get you the copy of the presentation as well. So with that, thank you again, everybody. Great presentation, great discussion here, and appreciate those that participated today. Have a great rest of the day.
Thank you. Yeah, thanks, everyone.
Thank you.
Yeah, thanks.
Bye.